Okay. Hi, welcome. Thank you. So, how many of you have been to Philippe's excellent talk just before this one? Yeah, excellent. So we can leave. It almost feels a little bit pointless now to talk about all of this. That's why I decided basically the talk has two parts. One is more like the how and the why and the historical perspective, so to speak. I'm gonna try to get through this a little bit quicker because we are at a security conference. I think you all believe me that cross-site request forgery does exist, yeah, which not everyone does. And then we're going to focus more on the BFF part and how we build it, how you can build it, and some things we learned along the way, I guess. Okay, so my name is Dominick. I do security for a living, and I've built a couple of projects like Identity Server and also this BFF library that we built based on lessons learned from this talk and many other things. Oh yeah, and you can reach me here, and the slides are here on speaker deck, so if you want to have the slides afterwards, just feel free to download them. Good. So as I said, I want to first look a little bit at history, where we are, or where we are coming from, and then basically spending more time with this new-ish actually idea of a BFF, which is not best friends forever, as you probably know. It's backend for frontend. Yeah. So basically, if you've been doing that stuff for long enough, like me, right? I mean, I have the gray hair to prove it. You've seen multiple waves of guidance how to secure front-end applications, right? It's a bit like a pendulum, yeah, the way I see it is, yeah. First, we were swinging totally towards secure everything with cookies, right? And then cookies, we had some problems with that. And we were swinging more like secure everything with tokens, yeah. And now, as often, the truth, I guess, is somewhere in the middle, which brings us then to the backend for front-end pattern, which kind of tries to separate the concerns between the UI and the security parts, okay? So yeah, so let's go quickly over this. One thing, I've got called out recently on Hacker News saying this guy doesn't know anything about sparse and JavaScript, why would we listen to him, yeah? His security guidance doesn't apply to us, yeah? I wrote this blog post with the title "Sparse are dead," which is, of course, perfect clickbait, yeah? But I said in the very first sentence, yeah, that's a joke. People didn't read that far, I think. So whenever I talk about sparse or browser-based applications or Blazor, WASM, or whatever you want to call it, it's from my point of view, which is typically business applications. Okay, so we have a browser-based application running in the browser. I very often deal with authentication, typically via OpenID Connect, for single sign-on purposes, for federation, software as a service, all of these scenarios. And I pretty often deal with then you have to call APIs from that front end, and very often OAuth is somewhere used in that architecture. So that's kind of like the world I'm living in, and I totally acknowledge that there might be sparse out there that don't have this architecture, and maybe for these sparse the talk doesn't apply. Who knows? I don't know them. Yeah. So, as I said, when I started writing web applications, right, it was like classic ASP, for example, Microsoft Active Server Pages, yeah, or afterwards ASP.NET, yeah, and pretty much everything was what the cool kids today call server-side rendered applications, right? It's a new invention, yeah? It means that the UI is coming from the server. And pretty much we use the post-back model, right? You render the page, there was a form, you click a button, you submit back to the server, and the cookie, right, was authenticating that post-back to the server, right? And then Microsoft, or at some point the Ajax term got coined, right? And Microsoft, does anyone remember the Ajax control toolkit for ASP.NET? Brilliant invention, right? You just slapped something on, no more flickering in the browser, which was the goal we wanted to achieve, right? It was horrible, technically. And again, it used this thing called, AJAX calls under the covers to avoid the postback, but it was still using cookies, of course, to secure the whole thing, right? And then at some point, cross-site request forgery was discovered, right? Which is exactly attacking this, that the browser is just sending the cookie on your behalf automatically. There's nothing you have to do, right? And I think the very first known to me big web application that was attacked using CServe was Amazon, right? You remember the one-click buy button, where you had like a link on the web page and you click the link and you bought a book? And it was using basically the fact that you are logged into Amazon, the cookie travels along, you click the link, you buy the book. Now guess what? If I put up a blog post about my book, and I put like an image tag on that and put the image source to that one-click buy button, you're not only reading my blog post, you're also buying my book, right? And that was basically cross-site request forgery. And the way it worked is basically, you open a tab in your browser, you go to your application, you log in, the browser sends you an authentication cookie, and you're good to go, right? And now imagine you're opening another tab in the browser, you're going to evil.com, whatever, right? And then evil.com starts making HTTP calls to the application backend, yeah, calling something, and basically because the browser has an authentication cookie for the server-side app, it's going to send along that authentication cookie here as well, right? That doesn't even need AJAX, right? You could just do form postbacks or things like that, yeah. So that's cross-site request forgery. Normally, I would do a demo for that. As I said, I believe you that you believe me. Yeah. So that was a problem because people started securing their API-ish endpoints using cookies. Yeah. And when we discovered this, it became possible to call these API endpoints from a third party, right? From cross-site. That's where the name comes from. Yeah. And for everyone who did MVC in their life, they know there is a countermeasure for that, right? It's called anti-forgery tokens. Yeah? And the way anti-forgery tokens worked is that when you're rendering down a form, yeah, they are setting an anti-forgery cookie and they are embedding an anti-forgery token into the form field, right? Which is like an application-generated secret, if you like. And when you're posting back the form, both values post back, the cookie and the hidden field. You had a server-side filter running here that looked at both values. If they were fine, okay, good, we're good to go, okay? Pretty much every MVC developer in the world knows this, right? Because it was part of all the templates that Microsoft put out there. What about web APIs? Did you secure them in the same way? Well, in theory, yes, right? The solution could have been, right, you're rendering down the form, and then when you're making the AJAX call back, you're sending the cookie, and you are reading the value of that field here, and you're putting it on a header and sending back to the server. How many of you did that? A couple, right? But much less than everybody just said, like, yeah, MVC, right. Why? Because Microsoft was never including this in the templates, right? Many people didn't know about this, that you have to do this, yeah? And I did a lot of code reviews in my life where I found exactly that. All the MVC endpoints were perfectly secured, but the API endpoints were just open to cross-site request forgery. Yeah? So this was a problem, right? And this is now getting us closer to our story here, is the IETF saw that problem too, right? And the IETF said, okay, you know what, we're working on this OAuth spec. How about we try to solve the browser problem as well? And since at this moment in time, it all boiled down to that the cookies are the problems here, so why don't we replace the cookies with tokens, right? Tokens have this nice properties that they are not sent automatically by the browser. You have to explicitly send them, which means cross-site request forgery is not the issue here. Yeah? Also, people like the idea that with tokens, you could now send stuff cross-origin or cross-site, which you couldn't do with cookies. So there's actually, when you go back to the OAuth archives, every single email that they ever wrote about the OAuth spec is archived, yeah? And when you go back to 2009 or something, someone said like, we should think about OAuth for browser-based applications. And the immediate response was, why would you ever build an application using JavaScript? So they didn't consider this in the first place, but there were some people saying, like, yeah, this is going to be a thing, yeah, believe me. And so they started thinking about this. And by the time, like the code flow in OAuth did exist before, but the code flow didn't work because you could not do cross-origin AJAX calls in JavaScript, and that would be the prerequisite for getting the back-channel token. So they came up with this other thing called implicit flows, yeah, and the implicit flow, which kind of is an evil hack, right? And what the implicit flow tried to solve is doing cross-origin requests, and the solution for that was we're gonna basically make the whole OAuth thing work with redirects only, yeah, like top-level redirects, and we're gonna ship our tokens over URLs. Okay? So just, I'm sorry, but I have flows on my slide. Just to recap that, right? That's how implicit flow worked. You made a token request to the server sent you back the access token on the URL, and then you would store the access token inside of your browser, right? And then you would use it. Now, is that good from a security point of view? I mean, to make it short, no. Of course, transmission of tokens over URLs is leaky, as it can get. Okay? These URLs are ending up in log files, in browser histories, in reverse proxies, in referrer headers, right? And you could leak them with your own problems and so on. So there were lots of ways how you could leak those tokens. Right? And since they are bearer tokens, for all of you that know, came to my talk yesterday, they are bearer tokens. Once you have the token, you can use it. Yeah? So the first thing they try to fix now, and fast forwarding to today, is they deprecated this flow altogether because they thought, okay, the only reason we invented this flow was because certain things did not exist back then. For example, cross-origin AJAX calls, for example. Yeah. So they said, okay, now we have that course, right? Now we have that. We don't need this anymore, and we can make this much better, right? So they said, okay, and from now on, applications will use the code flow, the browser-based applications, which in a nutshell looks like this, right? You're first opening the front channel, doing all of your UI stuff, and then you're getting the actual access token over a back channel, yeah, like an AJAX call, basically, which means it does not need to be transmitted anymore over the URL. Okay? So they solved one problem, but you still have to store that token and manage it inside the browser, which is the other half of the equation, which Philip just explained in great detail, is not secure because we have the problem of cross-site scripting. And once you have cross-site scripting or other similar things, you can either exfiltrate that token or reuse some other state in the front end to get your own tokens, right? So that's the main problem here. Token storage is an unsolved problem in browsers. There is no secure storage in the browser, right? Every storage mechanism by design is accessible from JavaScript, and whatever is accessible from JavaScript is accessible from malicious JavaScript injected into your code, right? And again, I'm feeling like I'm repeating Philip's story here. It is on top of the OWASP top 10 for the last 15 years or 10 years or whatever, right? Some sort of injection attacks. Pretty cool. There's some research from Google showing that Spectre attacks, the thing where you can start, like Spectre was this attack against servers where you could start reading RAM on the server, that they also work in browsers, right? So you could potentially, with valid JavaScript, yeah, start poking around in the RAM of the browser process, for example. Yeah? So again, the browser is not a great place to store tokens. Yeah? That's why back then in the implicit flow, they thought like, yeah, okay, this is going to be a problem. That's why they did not allow refresh tokens in the first place, right? Because refresh tokens, if you leak an access token, that's bad. If you leak a refresh token, that's even worse because that allows the attacker to get new access tokens, right? So let me show you that. So that's a JavaScript library that we worked on many years ago. And basically, this is exactly doing what the OAuth spec was suggesting. You're driving the complete OpenID Connect and OAuth flow from the browser with code flow, Pixie, all the bells and whistles. Okay? So when I run this, right, I'm at the same design school as Philip. You log in, you're getting your login UI, all of the OAuth magic is happening, bam, tokens in the browser, right? And now the API can start, the client can start calling APIs. Of course, these tokens need to be stored somewhere, right? In this case, it is, where is it? What? Where are my tokens? They used to be in session storage. I don't know, that's weird. Let's restart. Log in. Huh? It doesn't matter. You get my point, yeah? I'm not sure why this is not working. This worked like an hour ago. But, they are somewhere in the browser, okay? In memory, in session storage, in local storage, IndexedDB, whatever. And when you're getting an injection attack of thoughts, you can steal that token, okay? So, as I said, and that's why originally the implicit flow disallowed refresh tokens, because to mitigate that risk. But refresh tokens are a way of doing session management for APIs, right? Because the access token will expire at some point, and then you need a new access token, right? I mean, that's just the way it works. There were replacement technologies for that, which I want to talk about next. In absence of refresh tokens, the OpenID Connect people invented a couple of workarounds again for being able to get new access tokens based on the session lifetime you have with the authorization server, called silent renew, and I'll show you that in a second. And another thing that is a concern for a business application is if the session ends on the authorization server or on the OpenID Connect provider, or if the user logs out somewhere, how do you send logout messages to your client applications, right? Which is in JavaScript a little bit more complicated because they're not, by definition, not connected. So they came up with a couple of techniques that I want to show you here. Not sure why this is not working. But you see here, so the first problem, let's say, is how do we send, the first problem is how do we get new tokens, okay? So you see there's this renew token button here, and the idea is that the application monitors the token lifetime, and when the token lifetime comes to an end, it silently gets a new token, okay? So, when I click the renew token button, you see what's happening here. It's hard to see, especially from the back. But for a short moment here, there's an iframe being opened to the authorization server back with a special parameter called prompt equals none, which basically says, don't expect this to be inside of a UI flow. It's just a way to silently get a new access token to replace the expiring access token in my front end. And the nice property about this approach is that it only works as long as the user has an existing session with the provider, right? Once the session ends, the iframe will be unauthenticated. There will be no token coming back, okay? And the other iframe you see here is one that points to an endpoint on the provider called the check session endpoint. And that idea here is that you opened an iframe in the origin of the OpenID Connect provider, and inside of that, there was code running checking if the user is still logged in on the server. Okay? And if the session ends on the server, it will post a message back to the hosting application saying, hey, session has ended, please log out the user in the front end. Okay, so these were the two session management features that they introduced a couple of years ago. Yeah? So when I do this, do I need classes for that? I guess I do. When I go to the token server here, yeah, and go here and log out, when I press the logout button, you know, that iframe will detect the cookie is gone, it will fire the event, and it's magic, you are signed out from your application. Okay? So that is how it used to work. And you know, part of the talk is how painful it is for developers to keep up with all of these recommendations that are changing all the time. Yeah? Now, this JavaScript library, that's kind of like a side story here, but the JavaScript library that you just saw that implemented all of this, silent renew, check session, and so on, that was written by us a couple of years ago. It's called OIDC Client.js. Is anyone using that? Yeah, a couple of people, yeah. It's an officially certified client library by the OpenID Foundation, so you know it's a blessed implementation, yeah. Brock, my colleague who was working on that, he didn't, well, he was frustrated maintaining it. Yeah, you know, JavaScript, you know, the whole JavaScript landscape is changing constantly. You know, people said like, okay, can we open a pop-up for login instead of doing redirect? Guess what? The pop-up, how to open a pop-up in a browser is not standardized across any browser. For example, it works different in Edge and whatever. You know, and you have to, you know, and all of these problems actually led us to stop maintaining the library. Okay. On one hand, it promoted, in our opinion, a bad style of storing the tokens in the browser. On the other hand, which I'll show you next, it is not really future-proof because browsers are changing. Yeah? So it is pretty much, well, it is a done deal that every browser will sooner or later change the way how they deal with cookies, especially so-called third-party cookies. Yeah, so basically cookies which are third-party to the current domain you are on. Yeah, and the official reason they're doing that is to stop, you know, tracking in the browser and advertising and so on. Yeah, and Safari did that already. Actually, already like 2 years ago. Yeah, they started third-party blocking any third-party cookie in your application. Chrome wanted to do it and postponed it because I think they were sued by the EU because all of their websites wouldn't work anymore. Because they're like these portal-style applications, right, which pull in iframes from all kinds of places and so on. But yeah, some people refer to that as the Google Chrome cookie apocalypse. Because does anyone remember when Google introduced same-site cookies like 3 years ago? Shit breaks, right? That's the same thing that's going to happen here again. Okay, so you've seen these two state management techniques, right? They were both using an iframe pointing to a third-party site, which is the OpenID Connect provider. And they both were relying on the fact that in this iframe, you are sending the session cookie along, right? This doesn't work anymore. Okay? So let me show you the absolute same application that I just ran. This here, localhost 5001 in Safari. Safari. I need my glasses. Okay, so looks almost the same. Yeah, so much for browser standardization. When I now, and stuff will happen now. Yeah, when I click the login link. But to explain what is happening is, I'm now pressing the login button. I go to the token server, come back with the tokens and everything. It's going to open the check session iframe. It's going to wait for the server to tell them, hey, they are logged out, right? But the iframe is opened across domain boundaries, meaning it's a third-party site from Safari's point of view. It will not send the session cookie along, and the token server will immediately tell the client the user is not even logged in. Okay? So when I do this, log in. Yeah? Of course, the renew token thing will not work either because it's based on the same technique of sending this session cookie across iframe boundaries. So long story short, this didn't work anymore, which then led people to make the decision, you know what? Now we're going to bring refresh tokens to the browser. Right? The implicit flow didn't allow it, but we're not using implicit flow anymore, right? The spec doesn't say anything about code flow, so it's allowed. Right? And now that this is kind of like where Philippe's talk started, right? Now under the assumption that browser-based applications have access and refresh tokens, right? And now you're running into all of these problems that we talked about in the previous talk. If they can be exfiltrated, it's bad. If they can be somehow abused to get new ones, it's bad. And you're opening up the attack surface considerably. Okay? Firefox will make that change as well. I think Brave, I can't remember, Brave has an option which is turned off right now. They already do it, yeah? Have you ever tried to open Microsoft Teams with Brave? They tell you, use an older browser, please. this one is too secure.
Firefox changed like 4 or 5 months ago as well.
Yeah, yeah. So
it's a different model, but they have like isolated cookie jars for separate domains. So it's going to work.
So it's coming. Okay? Every browser will change this behavior, which will break every application that you built, let's say 3 years ago, using the current best practices. Yeah? You know, some people argue that Chrome removing cookies from the browser is a way to stop all of the advertising and tracking networks besides Google's. But that's just, you know, conspiracy theories. Okay? Yeah. So yes, so we've seen that it doesn't work anymore. Yeah. So this leaves us kind of like in a limbo, right? I mean, the cookie-only way we saw has the cross-site request forgery problems. The token-only way has all of the cross-site scripting, and stuff doesn't work anymore the way we want it, and we are forced to pull in refresh tokens and so on. So we have to rethink all of this, I think. Yeah. Now it turns out there are some good browser changes as well. You know, like when we go back all the time to cross-site request forgery, we identified that the behavior how browsers deal with cookies is the main problem here, right? Because browsers are sending those cookies to whatever origin they came back in the first place. And even if I'm making cross-site requests, the browser will just take the cookie, send the cookie cross-site because they think it's where it belongs, right? So actually, maybe right from the start, they should have focused on solving that problem first. And that is what happened with this thing called same site. Or at least they reduced the attack surface considerably by introducing this thing called same site cookies. And what same site cookies means is when you get a cookie from site 1, it will only send that cookie back to site 1 if the post back or the call actually comes from site 1. Okay? And not site 2 to site 1, which you would have thought, wasn't that the case right from the start? Yeah? So, and you know, as I said, when Google introduced that feature, many applications were breaking. Yeah? But now, 2 years later or 3 years later, it is pretty much deployed in every single browser these days, and the behavior kind of is harmonized, mostly, I guess. So this is now a real feature we can use to build applications. Yeah? Which means we should maybe rethink the whole cookie approach before we even use tokens to solve it. Okay? At the same time, we mentioned it this morning already, there is some newer work going on at the IETF about how to secure browser-based applications. This has been a lingering issue for many, many years. Nobody wanted to touch it because, you know, they knew once you start writing that spec, you're going to open Pandora's box, and you will uncover many problems in the browser which are unrelated to OAuth and tokens, which is just, you know, just the way it is in browsers. Yeah. We also mentioned this morning, and I'm totally agreeing with Philip, that there are some things which are not perfect, but for me, the most essential part of that document is that it makes people aware of, you should think of your web applications in 2 terms. One is applications with a backend, and one is applications without a backend, right? Like the pipe dream of many JavaScript developers was, I'm just going to deploy my JS and my HTML on a CDN. That's all I need, right? I don't need a web server for that. I don't need a backend, right? I'm just deploying my application files, and then I'm a standalone application, right? Of course, if you are doing this, then you have to do your OAuth in the browser. You have to do your OpenID Connect in the browser. You have to store your tokens in the browser, because there is nothing else that could help you with that, right? So the more secure approach they are actually recommending is applications with a backend, meaning you have your browser-based application doing the UI, you have an application server that is doing all of the security stuff like OAuth flows, tokens, token storage, token management, and you have your backend resources that you access via, and that's the thing that throws many people off, via the application server. So the JavaScript does not make API calls anymore directly to the APIs. It is using the application server who has the tokens and manages the tokens to basically forward these calls, right? And that is now what we call, or what many people in the security space call, a backend for front-end architecture. Yeah? So in other words, I guess, the classic server-side model was like this. Everything was happening on the application server, right? These are the fundamental building blocks. You have your authentication OAuth library, you have session management, you have token management, and you have your UI. Okay? Now, the SPA era flipped this all around and basically made everything run in the browser. Yeah? And the model we are proposing with the BFF is this. Watch this nice animation. Okay? We are separating the concerns. Yeah? In the browser, you have the UI framework, right, doing all of the flashy stuff, and then all of the security stuff is going to the application server. Yeah? Okay. So how does it work? So I'm an ASP.NET Core guy, right? So that's what I did and what I built. And the good news is 80% of the building blocks are already part of the product. So many of that stuff is already in ASP.NET Core itself. So for OpenID Connect and OAuth, we have the OpenID Connect authentication handler in ASP.NET Core, which is really good, which is the best OpenID Connect client I've ever used, honestly. Yeah, it covers all of your requirements, the flows, Pixie, code flow, everything. Okay, so that's a proven server-side component, which is by lengths better than anything I've seen for JavaScript. Yeah. Session management, right? Cookies. Yeah. First-class citizen in ASP.NET Core. Token management, not so much. There's a library I wrote. I will show you that later. And then API endpoints. I will show you how to do that. And then ultimately, you have your static assets to serve your HTML, CSS, JavaScript, and so on for the UI. Okay? So, full disclosure, I worked on a commercial product called the BFF. It is exactly doing what I'm showing you. This is not about selling anything. The library is free for individuals and companies with less than $1 million of revenue. If you are above that threshold, you can afford it. Otherwise, just keep using it. Good. So, what are the building blocks if you would like to build a BFF using ASP.NET? First of all, you need a way to serve your static assets, right? JavaScript, HTML, CSS. That's where they have the so-called static files middleware in ASP.NET Core. You basically point to a directory on your hard disk, and then it just serves these things as a CDN, basically, yeah? Or a static file server. Authentication and token requests using the authentication handler. And then we have cookies. They support same-site cookies. They support all the bells and whistles. You could throw in host prefix cookies and other stuff. And then you can also layer on top additional anti-forgery protection, which I'll show you in a second as well. Yeah.
You can still host your files on the CDN if you want to, right?
Yes, I'll show that later as well. Yeah. Yes, absolutely. Okay, so the first thing, and that was a question this morning in the, don't know if the gentleman is here. He said, like, how do we expose log in and log out now to the front end if it's happening on the server, so to speak, right? And it's simple, right? All you have to do on the server side is you're just exposing two endpoints, log in and log out. And when the front end calls this login endpoint or the logout endpoint, you are triggering your server-side OpenID Connect library to start the login process or stop it. Okay? And the way you're doing that is by just plugging in the standard OpenID Connect authentication handler from Microsoft. You configure your OIDC stuff, right? Where is my authentication server, client ID, client secret? Interesting point, right? By using that approach, you are turning your SPA, which used to be a public client, into a confidential client, because now you are securely storing a secret. Yeah? You're using code flow, query response, and you are basically asking for the scopes like API access, and that's refresh tokens. Okay? And once this has happened, right, then the server-side library will issue a cookie, and once that cookie is established, in other words, you have a session, you basically, another good idea would be to expose an endpoint on the server, on the BFF, so that your JavaScript frontend can read the session information of the user, first name, last name, favorite color, whatever you want to expose, basically. Yeah? Even nicer is if you would find a way to do that without sliding the cookie. Yeah, because some customers use that also, this user endpoint for check session reasons, right? So you could imagine once a minute I ping the user endpoint to see if the user is still logged in. But that's counterproductive if by pinging the user endpoint you are sliding the cookie into the future, right? If you're using sliding expiration cookies. Good news, starting with .NET 6, you have a way to stop sliding expiration on a per request basis, which is quite nice. Okay? So, and then you plug in the cookie handler from Microsoft. Yeah? You set your expiration, your sliding or not. You set your same side. By the way, using this approach, you can use strict same side mode, which is quite nice because you're not handling a post back from the server anymore. You can basically use the highest same side mode to secure your cookies. That this might not be compatible with your application, because maybe you are having links between applications and this is not working with that, but it's possible, which was before that not easily possible. Okay, let's do this. Let's switch to a different demo. Okay, so here's my BFF host. It's a standard ASP.NET Core application. I'm adding MVC here because I have some controllers. I'll show you in a second. I'm adding some plumbing that we need with add_bff. And then, essentially, I'm doing exactly what I just told you. I'm adding a cookie, so support for cookies, and support for OpenID Connect on the server side. Okay? And then the three endpoints I just mentioned, like the login endpoint, the logout endpoint, and the user endpoint, they are basically added here using this, the endpoint system in ASP.NET Core, and that gives you these three local endpoints to trigger the three fundamental session management operations. Okay. Right. And when I run this, the front end is pure JavaScript, right? Look at that, a silly to-do application. Not written by me, because otherwise it would look even worse, yeah? But basically you see here, there's a login link, just like we had with our SPA before, and all it does is it goes to the login endpoint in the local application. Okay? And from a user perspective, it's doing exactly the same thing as before. It shows a login page, right? Login. Here we are, okay? If I would look at the cookies, maybe this is at least working. Yeah? So, that is a big cookie now, okay? That was another question this morning, like, since now you're storing the whole session information, including the access tokens and the claims, everything in the cookie, will the cookie get bigger? Yes, absolutely. Okay? And that is kind of like what ASP.NET Core does by default. It just puts everything in the cookie. They have this nifty mechanism that they know a cookie has a size of 4 kilobytes, and if you're exceeding that, they're going to open a second cookie and a third cookie and a fourth cookie, unless you're basically running out of cookies. Yeah? And they tell you, oh, look at that, there are 2 chunks here, and these 2 cookies are basically your session. Okay? This might be okay for you. This might be an issue, depending on the browser and your deployment scenario. But also, ASP.NET Core by default can just store everything in a server-side database or cache, and just emits a cookie with a GUID, right? And then on the way back, you just take the GUID, go to the server-side session, and rehydrate the whole thing. So there's no difference here from a user point of view. Okay? And that's all, as I said, standard ASP.NET Core. Same goes for the logout endpoint. Right? I click that. I go to my BFF. The BFF starts the logout, and I'm logged out again. Okay. So log in again, just to make sure it works twice. And this one here is the session, basically a way for the client application to get the session information, right? And what this is doing in my simple implementation, it's just basically echoing back the contents of the cookie, or the cookies, the claims in the cookie would be the right term. Yeah, and you see UI is much harder than security. It's almost there. But basically, that's what you would find in the cookie, right? These are the claims that your application might care about: the authentication method, session ID, subject ID, name, logout URL. When will the session expire is another information that you can proactively ask the server, for example, and so on. Yeah. Okay. Oh yeah, and actually, you can create to-do items, just to prove that. Yeah, and the way this works, the to-do items is of course via an API, right? So it's the next thing I guess we have to talk about. First, before we go to the API, let me talk about session change notifications. Yeah. So what if your application is actually relying on session change notifications from the provider? So what if you're building a business application, right? And the requirement is if the user logs out of any of your applications, all applications should get logged out at the same time. It's called single logout, right? The old technique was to open this cross-site iframe, right, and waiting for notifications for that. This doesn't work anymore. And for those people who did OpenID Connect, they might know the so-called front channel notifications as well, which is, again, using iframes, which doesn't work anymore across site boundaries. Yeah? Guess what? There's a third notification mechanism, which is called back channel logout notifications. And the way this works is basically that the token server posts a JSON web token to the back end of to the BFF, basically, right? To the BFF, and notifies the BFF, hey, the user has logged out from somewhere, either from the token server itself or from some other application. And then the BFF knows that the logout has occurred. It can kill the session server side, right? And then the next time the front end will query the user endpoint, it will say user is logged out. That's how you would implement this in this world. Yeah. Again, that's a piece we had to add because Microsoft does not support back-channel notifications yet. I would assume they do at some point because, Azure AD is by definition always a cross-site token service, right? It lives on login.microsoftonline.com, and once all of the browsers change their cookie behavior, every logout from Azure AD will be broken, which means they need to implement it at some point, right? Or you're using our implementation. Okay. Good, APIs. Yeah, so Philippe this morning said that a BFF could be almost like a completely generic piece of software, no logic in there, just basically a thing you run, configuration file. And that is definitely one of the styles that people use, and I'll show some styles later on. But when we implemented BFFs with customers, we identified, especially for more simpler applications, that they call lots of APIs that are only called by this one front end. They are never shared between anything else. Okay? So if you identify front-end exclusive APIs, then you have to ask yourself, is it worth putting them into a shared location, or should I just put them into the BFF directly? Right? So in other words, if you realize I'm only calling first-party, front-end, same site, same origin APIs, you don't need OAuth. There's no need to harm an access token here. Okay? You can put them directly into the backend, use the cookie to secure the communication, right? And that's exactly what we're doing with this to-do API here, right? So ultimately, this to-do controller is just an MVC controller. All right? Sitting in the BFF itself, it is secured by the same site cookie. No OAuth is needed for that. Okay? If you have APIs which are shared by multiple clients and multiple callers, then you can't use this technique, and I'll show you in a second how that would work. Good. Now, so I said earlier that with same-site cookies, right, we now have a nice security boundary by default if we want to secure our local APIs with cookies only, right? Because now with same-site cookies, they only travel within site boundaries. Now, that is good, and you get that by default now. But by definition, what same-site means is everything that's within that site is trusted, right? So if you have mycompany.com and you have 500 subdomains, everyone trusts every other subdomain on that company web DNS name, whatever you call it, right? So if you trust, if you're running your banking application on one subdomain and the marketing guys run their CRM on this other thing, do you trust them? Right? So that's one thing. There have been historically attacks where attackers were able to take over subdomains from companies, right? And now a same-site domain runs under attacker control. Yeah? That's why, actually, Philippe, all credit goes to you. You convinced me that we need something else than just same-site protection. So we added anti-forgery protection as well on top, so that you can secure your BFF not only for same-site sandboxing, but for same-origin sandboxing. And this blew my mind, by the way. Anti-forgery tokens, right? In ASP.NET Core, they are these long things that they generate and hash and blah, blah, blah. And as I learned from Philippe, you don't need all of this. Just put an extra header on your HTTP call, use a custom header name, right? And by virtue of now requiring a cookie and a custom header, this will always trigger CORS pre-flight requests if you would make that call cross-origin. Yeah? What does it even mean? CORS allows, the reason why CORS exists is to allow cross-origin AJAX calls, right? And CORS has two modes. Yeah, one is if you're doing a simple request, as they call it, a GET request, for example, they make the request and expect on the way back some special header saying like, this was okay to do. Okay? But if you're doing a complex request, which I think means, for example, with credentials and a custom header, then they're doing a so-called pre-flight request where they first ask the API, I'm going to make this request now. Is this okay? And if the API doesn't respond with the right data, the browser won't do it. Okay? Now, going back to Spectre attacks, where I said, like, maybe you're able to read the RAM on the browser. It's actually good to do pre-flight and not even have the data in the first place, right? So it's a little bit, kind of nice. Anyways, so it turns out by just adding a static custom header to your AJAX calls and enforcing them on the server side, you're automatically getting single origin, like a same origin sandbox. Okay? So that's what we do. And with all of these frameworks, you can just write some handler that automatically adds that header on outgoing calls. And if you want to see it on the server side, here, that's a middleware that we call BFF, the BFF middleware. And what this enforces is that when you're making an API call to an endpoint that is marked as a BFF endpoint, it ensures or enforces that this static XCserve header is present, otherwise it will reject the call. Okay? Cool. So, that's local APIs.
Can I add a side note?
Yeah.
This only works if you don't have a CORS policy that actually allows other origins. So if you combine this with a CORS policy, it's just like, whatever, we accept anything from anywhere, then
sure.
None of this works.
Yes. So yes, you're very right. Thank you. And in this model here, we assume that the front end and the back end application are the same application, so there is no CORS, right?
Same origin.
Yes. I'll show you later some deployment models that other people like to do where CORS is required, and then you start having to be careful about what you open up. Yeah? Yes. Good. Yeah, okay, so local APIs are easy. What if you don't want to do that? Yeah, what if you want to keep your BFF as generic as possible and don't want to do business logic in there? Or you want to call APIs which are shared by other clients, for example, right? And ultimately the answer is reverse proxy. Okay, so you somehow need to proxy them from the BFF to the ultimate location. And why do you need to do that? Basically, you secure the connection between the front end and the BFF using the cookie and the forgery header. And then on the server side, we store the access token. And then the reverse proxy will take the access token and call that remote API on behalf of the currently logged on user. Okay? Now, many ways how to do that. You could run a real reverse proxy. We have customers doing this with Kubernetes ingress controllers and all kinds of things. What I really like is a package from Microsoft called YARP, which is probably so let's say it's easy to Google YARP. It's going to be your first hit, but it's a really stupid name. It stands for yet another reverse proxy. Okay? Haha. Anyways, but the nice thing about YARP is it is a reverse proxy middleware. So you can put that reverse proxy into your application and basically say something like, if a call comes in on /API, forward this to server 5/API. And you don't have to run a separate reverse proxy server or product, like an IT pro thing. It is actually part of your BFF host. Okay? So, in other words, if we want to enable remote APIs, you can basically just do something like this. In your pipeline on the BFF, basically say, hey, whenever a call comes in on /todos, the actual API server is living here. Oh, and by the way, while forwarding that API call, attach the access token of the currently logged on user. Okay? So basically, by doing this, and then just to prove my point, I'm going to uncomment our local API, and now I'm going to run the to-do API on a separate host. Okay, and this separate host is now just a normal API, right? Oops, that is doing JWT, right? That's just a standalone API that expects the token from the token server. And it doesn't make any assumptions who is calling it. So let's run this backend host, right? Run the front-end host. And when I now log out and log in, see, my to-do API is still working, but now it's living on a different API server. And it's completely transparent to the front-end application. And you can move your API at any point in time. Let's say it started out as an exclusive API, now you want to share it, or the other way around. You just add this reverse proxy route, and your application doesn't need to change, and there are no tokens in the front end. Yeah? Okay, so we are almost done. So, yeah, so that's that. Oh, yeah, and by the way, I should mention, the way we implemented this forwarding thing is it now does the cookie check first, right? If you're actually allowed to access that proxied endpoint, it does the anti-forgery check, and then it only does that if there is actually a token for the user available. So, yeah, so basically it hides all of that endpoints behind multiple additional security checks. Yeah? Token management. Yes. So one feature I am missing from Microsoft's OpenID Connect plumbing is token management. So they did a great job of getting the initial access token and getting the initial refresh token, but that's where they stop. Okay, and I think I told them like at least 5 years ago that this is missing, and every single application that does OAuth needs to do refresh token handling, and why isn't that built into their own libraries? And it didn't happen, long story short. Okay, so I wrote a library for that. It's here, it's free, Apache 2. And you can just plug that into ASP.NET Core, and it does exactly that. It keeps track of access token lifetimes. Once the access token is about to expire, it will use the refresh token, get a new access token, and basically make sure that your application always has a valid access token to call your APIs. Yeah? I can't demo that now because we're running out of time. Yes. So the last thing I want to talk about here is the various BFF styles now. Yeah, so when you present this architecture to customers or whoever, you will get mixed reactions. You know, some people don't like the reverse proxy part. Some people think it's too much complexity to build a BFF. And we had this discussion already in the morning, right? But it is the only way to implement a SPA and keeping the tokens out of the browser. Full stop. Okay? So probably the most simplistic way to deploy a BFF would be you have your domain here where the application comes from. Here's your BFF host with the plumbing, with your endpoints, with your UI assets, and you reverse proxy to your API endpoints if need be. Right? That's exactly what I showed you in this simple demo. Now, that works fine, I think, for smaller applications, for smaller application teams that own all the bits and pieces, that own the front end, own the back end. They use the same programming technologies, I guess, yeah, like the same IDE, maybe, and things like that. So in other words, if you're a .NET shop, okay, then this is perfect, right? Once the teams get bigger, maybe they want to use different technologies and so on, then we very, very often see now basically a split host architecture, yeah? And one flavor of a split host architecture would be this, where basically your UI comes from one URL, which could be a CDN, and the BFF lives on a different domain or different, typically a different subdomain, you know, that you get the same side thing. And now, of course, the consequence of that is, as you rightly say, now you need cores. Right? Because now your UI, your JavaScript, the caller, now tries to cross-origin call API endpoints. And now you have to open up the origin, in this case app.company.com, to the backend. And now you have to be careful, of course, right? Because we have anti-forgery protection. If you open it up too much, like allow all headers or whatever, yeah, or allow all origins, you know, people do stuff like that, then of course the anti-forgery protection is gone. Yeah? But it's totally viable to do it like this, but you need to understand how CORS works to create the right CORS policy. Another architecture I've recently seen that gets around that problem looks like this. Ooh. Yeah, basically using two reverse proxies. Yeah, where basically the application comes from here, and now actually the front end comes from here, the BFF comes from here, but from a browser point of view, they all look like the same backend because there's a reverse proxy proxying in both directions, basically. That gets you around the CORS problem, but now you have two reverse proxies. And some people say, like, yeah, come on, look at the web. There are 15 reverse proxies already on the way to the application host. So what's one more, right? Yeah, it's up to you, right? And the very last pattern I want to show you, which we touched upon very briefly this morning, is what the IETF calls the token mediating BFF. Now that looks weird, because now the front end starts calling APIs again directly. So they have a section in their spec that says, if you can't go full BFF for whatever reason, and by the way, full BFF is the more secure version of this. That's what they literally say, is then you could go like, as Philippe called it, half-assed BFF, or partial BFF, maybe. The idea is that all of the token handling still happens on the back end, refresh tokens, flows, and so on. And then you are exposing a token endpoint to the front end, where the front end can get an access token, but no refresh token, and then call the APIs directly. Now, these access tokens would typically be very short-lived, right? So that you are minimizing the risk of token exfiltration, or the effectiveness at least. But of course, this only goes halfway, right? While this removes some of the concerns, it does not remove the concern of we don't want tokens in the browser, right? Some cloud vendors say this is the better approach for scalability. I don't know. I'm not a cloud vendor. I don't know. But there is some trade-off somewhere, right? It is definitely not as easy as just doing everything in the browser. You need to have some trade-off somewhere, full BFF, split host, single host, TMI, they all have their little pros and cons. I personally would not do this if I'm not forced to do it. I would rather go for the full BFF style approach, but just to make you aware that this also exists. Great. Right on time. Yeah, so thank you. I think you can read this yourself. It's obvious. Yeah. Web security is hard. Okay? That's the summary here. And I am 100% with Philippe saying you cannot, for security reasons, drive OAuth and OpenID Connect from JavaScript. It's a problem, okay? And the BFF is the solution to that, at least from my point of view. And now you can ask me anything. Thank you. Before we get kicked out, yeah?
First question is, if you're using this for remote APIs, so you're doing it like reverse proxy, does this impose any issues or I guess what would be the best practices for dealing with persistent connections like WebSockets, GraphQL?
So YARP, good news, YARP fully supports WebSockets and HTTP2 and all the bells, gRPC and all the bells and whistles, which is quite nice.
Okay.
Yeah.
And another question, if I can. So as like a cloud engineer guy, that's kind of what I do. The nice thing about Bearer tokens is that I can have a distributed application and fail over between all sorts of stuff and it doesn't really care. But if I'm using sessions to the cookies, I now need to implement some sort of stickiness, right?
No.
Or wouldn't the BFF application need to know about that session and then store the token?
So the question is, does BFF imply sticky sessions? And I think the answer is no. You can have a cluster of BFF and endpoints, right? Which share the same cookie signature keys and everything, and you can do the same failover techniques as with any other architecture.
So you'd still have to have a live replication of all the tokens that you're storing on behalf of your user.
Yeah, I mean, the tokens could be stored in the cookie itself, or the cookie is just mere a marker for the session, and the actual tokens are stored server-side. But BFF does not imply stickiness, no.
You can have a stateless implementation where you just put all the state in a cookie to the browser. There's no real risk of exfiltration if you secure your cookie properly. You can't get it out anyway. And the refresh token can't be used without authentication, so that's protected. And if you really want to, you can encrypt the cookie before sending it, and then nobody can read it anyway. So you can make this perfectly stateless without sticky sessions or anything on the source.
Yep. Last question, yeah? Incremental consent. You mean that spec that got cancelled 5 years ago? I mean, just like you would deal with anything else, right? I mean, if incremental consent is needed, you need to go back to the token server, somehow signal that you need more consent. They will take care of the UI and then send you back tokens. I mean, that's nothing special for the BFF. It is complicated either way you're using it. Okay, cool. Thanks. Bye-bye.